Hi everyone. So let's begin with the statement that error handling is crucial. I think it's one of the things that distinguish real production-grade system from a simple proof of concept or from a simple internal tool that we may use for some tasks. So it's pretty important that we do this correctly, and yet we don't talk about this so often as we should have. So I want to make a progress here. I want to talk about errors. I want to see some patterns that we may use. Because the other thing is that error handling is really complex. And let's look at a simple example. We have a simple function that is used to cancel a job, a thing that may happen in almost all systems. Pretty simple logic. We take the job from the database, set some fields, and save the job back to the database. And obviously, we cannot ship that code to production. We know that we cannot assume that everything will go fine. We have to assume that something may go wrong. So yet we add error handling. And we can see that this code got much bigger. We have to check whether the job exists in the database. We have to check whether the user has permission to cancel the job. We have to check if the job is in a correct state. And we do that all over the code base. Almost every function we write, every piece of logic we have in our system have some error handling, have some paths that may go incorrectly, and we have to make sure that we handle them. But when we talk about designing code, we don't often talk about errors. We focus on the happy path, we focus on design patterns and architecture that accomplish the goal that we are trying to accomplish. And we treat error handling as something that is like on the side. We should design the error handling tool. We should do it in a meaningful way. And in order to do that, we have to decide how to do that. And we have to know what errors we are handling. Because the thing is that not errors are equal. They have different sources, they have different consequences. And because of that, they should be handled differently. So when it comes to sources of errors, we have obviously the users who may use the application incorrectly. The simplest example here is a form that user has to fill in, and they can make some errors that we show and trigger some validation. We may have errors coming from different services. So we may use an external service like a payment gateway, or we may use our own services running in the same cluster. And both of those can be either down or return an unsuccessful response. For example, payment gateway can tell us that the user has not enough funds to pay for something. We have errors coming from infrastructure. Think about database problem, database being down, or its CPU may be overused. We have things like network problems, operating system problems, hardware problems. And finally, we have errors coming from our own mistakes. We as developers cannot write perfect code. If we're using a function wrong, if we make the order of the functions incorrect, if we, by mistake, delete some data, or forget to do a migration process correctly, we are causing some errors. And each of these types of errors require a different strategy. So let's now look at what we have and what is common in the Elixir community. And the most common one, probably, and the most talked about, is the let it crash approach. Here we are dealing with things that are unexpected. This is not a correct behavior of the system. That is something that is hard to test and hard to debug. So we are dealing mostly with things connected to infrastructure or other services being down or unresponsive. So we cannot deal with these things in any meaningful way. We often don't have the power to fix those errors, but we have to do something. And we decide to crash. Why? For two reasons. First of all, we have to protect our system. We have to make sure that even if the state is corrupted, we don't let users do anything dangerous. We don't want to corrupt the state even more. The second reason is that sometimes crashing and restarting may help. This is the whole idea of let it crash. It is to crash the process if we don't have the power to fix the bug and let someone else handle that, whether it's a supervisor who restarts a process or a user who just clicks the button twice. On the other end of the spectrum, we have error tuples, which are commonly used in the Elixir community. Here we are dealing with things that are expected, that are predictable. They are the correct behavior of the system because they are part of the domain logic. If the user doesn't have the funds to pay something, we expect that to happen. We can write tests for this case. So we can easily deal with that. So we use error tuples to return a message that is meaningful, either to the user or to some other part of the code. We do that because we hope that somebody else can fix the problem for us, because we know how. So how these two approaches deal with different types of errors? And when it comes to user errors, we deal with them mostly with error tuples. When it comes to other services, we sometimes use error tuples. For example, when the user doesn't have funds. Sometimes we crash. If the service is down and we don't know what to do, we can crash. When it comes to infrastructure, we mostly use let it crash approach because it's rarely something that we can fix. Sometimes we can retry. But when it comes to errors made by our mistakes, there's nothing that we can do using these two approaches because we don't want the system to crash. If I run a migration process and I lose some data during that process, I don't want the user to see the crash. But I don't want the user to see an error either, because if something is wrong, and it is wrong because of my mistake, and it requires my actions to fix that, I don't want to show the error to the user, because it's confusing. It loses trust, loses confidence, and it makes the system harder to use. But we are too used to these ways. We are too used to writing code like that uses case statement, pattern matching to match on errors and return them back. We don't think about errors in a way that we should. We don't think about how is this error even possible. We don't think about whether the error is something that some other part of the code can understand, interpret, and fix, or whether the users can fix the error. And it turns out that, as Martin said, the best way of dealing with errors is to not make them. Instead of trying to deal with something that happened, let's try to prevent that from happening. Let's eliminate error. Let's write code that is impossible to use incorrectly. And here I would like to share 3 patterns, 3 different tactics of dealing with that. And the simplest one is using defaults in a nice way. So let's look at this code. This code is used to fetch some settings. In our systems, we have used this code to store things like whether the user wants to receive a notification or not for different kind of actions. And we had code like that fetches the setting from the database. If the data is here, it returns an OK tuple. If the data is missing, we return an error tuple. But if you think about these 3 questions that I shown you, and you think about how is this error possible, you can come to a conclusion that it shouldn't be. The only reason that the settings are not there is because some version of the code forgot to insert the settings when the user was created, or that the settings was lost somehow. This case cannot be handled either by the user or by any other code. Maybe it can, but it requires another code, which is not useful. So instead of trying to return an error, saying that something is wrong, let's try to prevent that. We can use a code like that. If there are no settings in the database, we just return the default one. And not only does it mean that this code no longer can return an error, but it means that we can remove some other parts of the code that are responsible for inserting the settings in the first place. And we only use the database if the settings change. The second pattern, and this is getting both harder and more valuable, is using more declarative operations and thinking more declaratively. So let's look again at the code that cancels a job. It is often that we think imperatively. We think about what to do, what are the steps, what are the instructions to do. Thinking more declaratively means that we don't care about instructions. We want to think about the end goal, the end state. We want to think about what should be the outcome of the function. And if we think that way, we see that the outcome of this function is that after calling it, the job should be cancelled. We don't care that this code should cancel the job, but the job should be cancelled after calling it. And if we think that way, if we think about the final state, we see that this error is not valuable, because if the function is called twice, because the user might just click the button twice, or some other service might retry the request if it doesn't get a response. If the function is called twice, it's fine. We reached the end state that we wanted. So instead of returning an error, we can return a successful response. It will be much easier to use. It will be much more predictable. It won't cause us any bad surprises. And the third pattern, and it is both the hardest to use in real-life project, but it gives a lot of value. And the example here is inspired by the same talk that Tatiana mentioned, the talk by Greg Young that I have linked in the end. Let's imagine that we are building a warehouse management application. And we have a function that takes the product off the shelf. And the code is pretty straightforward. We check if the product is on the shelf, and if it is, we mark the product as removed. And if the product is not there, we return an error. And you might say that it is fine. It is pretty simple. We can easily test that condition. But when you stop treating your system as a source of truth, because we often do that. We often think that if something is in our database, it is there, and it is the truth. In real life, it's not that case, because if we get that error, but we have an employee, real human in the warehouse, that is taking the product off the shelf and trying to put this information into the system, if he gets an error like that, it won't prevent him from doing that. He will just ignore the error and move on. And by doing that, not only we make it annoying to use the system, but we also lose an important piece of information. Because maybe we want to do that. Maybe if something is wrong, maybe if the version of the word that we have in our database, if it doesn't match the real word, it's valuable information, because somebody should be notified. Maybe there's a bug in the system that we should fix, but maybe it's just people making mistakes all the time. And we should know about that, right? Because if constantly we are dealing with this kind of mistakes, maybe there's some process to be optimized in real life. Maybe it's valuable information, so we should gather metrics of how often it happens. So the important thing here is to realize that we cannot prevent people from making mistakes. And trying to always handle that error is like handling that in a way that prevents user from doing that is not valuable. Because not all errors are bad. Some of them are useful. Some of them provide a real valuable information about how people use our software. So error handling code has to be designed. We have to talk more about edge cases. We have to talk more about what each error means, whether it's valuable for us or not, whether it can be recovered from or not. Because most of the logic, interesting logic that we have in our system is heavily relied on the error handling. It's not, the most complexity is not in the things that we do, but in the rules that have to be accomplished for this thing to be done. And for the last 2 minutes, I want to explain why I believe this topic is important, regardless of the error handling. Because I used to believe that software design is about having clever ideas, being clever, having experience, choosing a good architecture, and following that. And it's not a good way of thinking. We cannot rely on our intuition. I used to do that. When I gained experience, I kind of knew that this decision that I was making was a good one, but I couldn't explain why. And this means that not only this makes discussions with teammates harder, but you cannot make good conclusions from mistakes. If you make a decision based on intuition only, and it turns out the decision was incorrect, you cannot learn from that. If you use facts rather than opinion, it's much easier. So I believe that having this clear list of questions, like I've showed you before, how is this error possible? Is this something we can handle? And having a list of patterns that reappear over and over again, like defaults, like declarative operations, like fighting the real world. Having all of that, it makes it much easier for me to design. It makes much easier for me to have a productive discussions that are based on facts, not opinion, and on things that can be verified later. So we should approach the design process more thoughtfully, not rely on intuition, not rely on something that we heard on a conference like that, but think about how we make decisions. We should gather as many questions, as many patterns and strategies as possible, and share them. Share how we make decisions. Instead of writing another article, writing another talk about the cool new way of doing something, let's write about how we make the decision. Let's talk about how we make the decision. And with that, these are the credits. A Philosophy of Software Design is the book that introduced me to the concept of eliminating errors. The Art of Destroying Software is the talk that Tatiana also mentioned. It is amazing and you should really watch it. And that is it. I am Maciej, thanks for coming, and I am happy to chat after this, or maybe if we have time for questions, I am happy to take them. Thank you.
Great talk. I actually think we have room for one question, if anyone has a question.
Thank you. Your last section was very good. Yeah. Oh, it was all good, but I'm particularly interested in your last section. Do you have any references for that, for these heuristics?
For all of them, or for the last heuristic?
Both.
For all of them? No, this is just something that I noticed in my code bases, and these are the things that are like happening really often. And the way I approach this is that I started making a list of those things. So every time I happen to eliminate some error, I try to think, what is the pattern here? Is this something that can be generalized? And I make a list. I have a list in my notepad of strategies and questions to ask.
And are you willing to put those on a blog, for example?
I'm thinking about that, but doing that in a way that is not too long is really hard. But I will keep that in mind. I will try to do that.
Thank you.
Thanks for the question.
Anyone else? Down there.
I'm just curious, when you diagram, because you were saying to diagram or understand the errors as part of like the system. Are your diagrams any different, or do you use like any strategies for trying to like architect like flow through like a software and how the errors come back, and could you maybe describe that process?
Okay, so I would say that the most important thing is to imagine how the end user will use the application. So you have to put yourself in the user's shoes and imagine what will happen, what can go wrong, and is there something that we can do to prevent that. So the real use case I had with that is that we are doing right now an application related to logistics, and we had an error that said that you cannot start a job until some time. But it turned out that it's not useful, because when the user is there, when the truck is there and they are loading the package on the truck, the app shouldn't be able to tell them, no, don't do that, because it's already happening. So if you imagine how the users use the application in real world, if you try to analyze that, you can come up with ways of reducing this error handling and doing something useful instead.
Thank you very much.
Thanks.